Thanks, great to be here. My name is Jakub, I'm the founder and CEO of Zeta Alpha, and I want to talk about how we can bring sort of the very exciting world of frontier AI models, OpenAI, Anthropic, uh, together with the engineering practice here at the Hannover Messe, where a lot of the machines and the parts that we make are represented in 3D, in CAD models. And so what I want to kind of sketch out for you is a way that we can bridge this gap and allow engineering organizations to understand their parts and their inventory as they are originally created in CAD. And this is a joint work with Batu, an AI engineer at Zeta Alpha. So who here is working with CAD models in some way or form? Can I see some arms? All right, so about half of the audience, who's working with frontier models, uh, ChatGPT, Claude, etc., Copilot, almost everyone, right? So I think let's dive in a little bit why part reuse is the use case that we want to focus on. So in engineering organizations, it's generally the case that reusing proven parts beats redesigning from scratch, right? There's a couple of very good reasons for that. Obviously, if you are reusing parts, you have higher volumes and you have less stock to keep, so it leads to lower cost. You can go faster because the units are in stock and they're already tried and proven, which also leads to higher quality because you have already battle tested these parts in production. And last but not least, in your engineering organization, redesigning leads to a lot of effort, right? It's a long cycle from the initial CAD design all the way to production at scale. The problem has been in so many larger organizations have kind of ended up with large portfolios of thousands or if not millions of parts. And the problem has been findability. So parts reuse is great if you can reliably find them. And this information is of course in CAD systems, in product lifecycle management systems, but also in many other systems, right? You have sort of the tribal knowledge, which is in people's heads, but you also have many documents, test reports, product data sheets, experimental data from testing, etc. And classical methods have not really been adequate, right? So we think that if you can marry this world of modern sort of agentic, RAG, frontier AI models, which are really smart these days, with understanding the geometric and functional requirements in CAD models, that can come to the rescue. So the problem is that these frontier AI models, they are really smart. They understand unstructured data, text, they understand images, they understand voice, they understand code and structured data, but they were never really trained to understand CAD models. So this is kind of really a mismatch of information types. And of course, there's also other models, so not all models understand each other, but I won't talk about that. So with Zeta Alpha, we are founded in Amsterdam, have an office in San Francisco, working with a lot of customers in industry to build this AI foundation layer for knowledge, because we think that knowledge reuse is a huge problem with an aging workforce, and we have quite a lot of pretty solid customers here at the Hannover Messe with companies like Festo, Ödif, but also a lot of clients in other industries. And we have a booth in Hall 11, by the way. So our sort of long-term vision is that AI can become this company brain. You have many different information sources in silos, right? In your ERP system, in your CRM system, in your SharePoint, in your product lifecycle management system, in notes people have on their own drives or on their own laptops, in email, etc. And we think that if you are able to connect all these different data sources, you can really connect the dots across industry-specific knowledge, both internal and external to the company, right? You don't even have all the documents internally. And what we see in industry is that this really requires a high degree of customization because of the heterogeneous enterprise IT landscape, but also because of the unique expertise that engineering for your products requires. So we think that sort of this vision can eventually solve the decades-long puzzle. I think it comes from Siemens, this quote, if only the company knew what the company knows. And if you're interested to read more, there's a blog that I wrote on the Hannover Messe website about AI for industrial knowledge. So industry is also inherently multimodal, right? We're not talking about documents, we're talking about photos, technical drawings, videos of machine behavior, chemical formulas, maybe geographical information, tabular or time series information coming from the lab, and now also in more and more 3D models. So just to kind of give you an overview of how we deal with that. So Zeta Alpha is an end-to-end knowledge foundation platform ranging from the data sources, ingesting from SharePoint and all the different data sources, through customizable processing pipelines, and eventually making this knowledge available to end users through search, through conversational interfaces, or through behind-the-scenes agentic workflows. So here at the Hannover Messe this week, we have unveiled 3D model support, which means basically that you can take 3D files from many of the industry-leading CAD software systems and just process them through this pipeline. But yeah, there's processing and processing, right? So I'm going to talk a little bit more about how that works in more detail. So what that allows you to do is actually have somewhat complicated assembly for a helicopter rotor, and we are able not only to understand the 3D shapes, but also the functional information, and we define CAD 3D model specific AI agents, which are able to do reasoning and question answering with that information. So here I'm pointing at a particular part there, this little pitch control lever there, and I can point at it in the 3D visualization and kind of drag it into my chat, and it has that context plus the whole 3D model plus also all the functional metadata and all the other documents in your collection. So at the core of this is of course retrieval augmented generation. Are people familiar with this concept? So basically it connects the frontier AI models to your own private information. Of course, the concept is really simple. 2 years ago, it was kind of introduced as, you just put your data in a vector search engine and then you inject it into the context of the LLM, that's problem solved. Reality is not as simple as that. In fact, this stack has evolved into more kind of agentic RAG pipelines, where you not only have a large language model, but actually a vision language model, VLM, which is able to understand pictures, so 2D pictures and text and code and other types of objects, and then it reasons and plans how to solve the task using a search engine, which is probably a more complicated search engine. Just a vector search engine, you probably want structured metadata, filters, graphs, all kinds of different combinations of searches. And you also want to use existing tools, whether they are existing APIs or interfaces to other systems that you have, or specific tools for CAD or chemistry of what have you. And more recently, this has really evolved into this kind of multi-agent system. So some of the use cases I'm going to be talking about, which talk about kind of supply chain risk of certain families of parts, actually use this pattern where the orchestrator makes a plan and there are specific agents with skills that are targeted to particular things, like looking up price or finding functionally equivalent parts or understanding really well the hierarchical structure of an assembly. And so these multi-agent systems can kind of decompose the task, plan, use tools, store intermediate data in memory, look up things in a search engine, look up things in external APIs, and then finally synthesize the task outcome. And some of them can work for a really long time. So this is not just chat, where you get an answer immediately. It can maybe work for minutes or hours in the background to really get the information for all the data points. So of course there has been in the past already quite a lot of work on part reuse using geometric shape-based information, right? So there are sort of the classical workhorses like GeoLess or CAD, which are kind of on the parameterized shapes, able to pick out near duplicates from large libraries of components. However, these have been very hard to combine with, for example, manufacturing information or other unstructured data that does not live in those CAD files. There's a couple of other AI approaches, for example, deep CAD embeddings, a paper by AutoCAD people, or manufacturing-aware feature similarity, which have kind of very CAD-specific modeling and train from scratch more complicated AI architectures to understand these models. And then there's kind of things taken from the, let's say, from the 3D physical intelligence domain, like point clouds and voxels and meshes, where you build specific AI models in those spaces. The problem with many of these approaches is they're very hard to integrate with frontier AI models, because frontier AI models do not understand point clouds or graph network representations. So we take a much more somewhat simple approach with some heuristics based on the fact that these current frontier vision language models, which are transformer models, actually understand both 2D and text really well. So presenting a picture of the part to the image encoder and asking questions about it is actually able to make a very decent textual description of all the different aspects, and you can prompt it to focus on different types of things, which can yield you a very rich semantic representation of the shape of the part, either using textual description, or if you have an open source AI model where you can actually go inside the model and grab the activations from the model, you can get a visual embedding. And with all of these sort of modern frontier models, whether they are, OpenAI or Anthropic closed models, or open models like Gemma 4 or QN 3.5, you can basically do very similar things in the vision language domain. So what we are doing, this is sort of the core of the approach that we are taking here. So we unify all of these different sort of native binary CAD formats from the different software manufacturers into a unified exchange format, which is STEP, right? You lose maybe some details, but you have sort of the 3D shape, and you have the many of the functional information, like manufacturing and dimensions and all these kind of things. And then using our own smart feature detection and view selection tool, we actually generate many different 2D renderings of the 3D model, which are focused on particular features. So for example, there's some kind of mounting bracket with a particular number of holes, and you kind of zoom in on that, and you take a 2D picture of that from a couple of different angles, which gives the VLM a good representation of that shape and its properties. And then basically you end up with a kind of photo album of the whole CAD model from different scales and different perspectives. And that is then fed into a classical VLM where the rest of the metadata functions as context, and you're able to actually derive a semantically meaningful representation that captures the shape, but also the other metadata and functional information in the document. And then you can use basically that as filters on your search and define all kinds of hybrid search processes and AI agents on top of that. So let me give you some examples. Oh yeah, what is really important is that you don't have only the CAD models, but you also have all the other information. So, your bill of materials, your supplier documents, your inspection reports, your work instructions. So you want to do semantic search across all of these different information sources, and then combine the geometric and functional and connect the dots. Do multi-hop reasoning, traverse, for example, the assembly tree and reason about availability or price of certain subcomponents. And then eventually you want to build these automated engineering agents that can do sort of very valuable long-term tasks like risk review or compliance review or simply part replacement. So let's look at sort of semantic similarity search. Within parts, you can use natural language, right? The classical problem that because of naming, things were hard to find. Um, and you don't only want to look at the official name of the part, but you want to look at the functional aspects and tolerances and dimensions and materials and all that. So you can add all of that to your query, but you can also search by picture. If you have a photo of the part, you just upload the photo and do a multimodal search with a query by image. And that will not only be able to find the corresponding parts, but also all this other information which is tied to the part through this connecting the dots. And of course, always with traceable source verification. So this is a somewhat more sophisticated example about parts replacements. So here we're basically prompting a specific set of AI agents for this particular part to find a number of best reuse options, including price, availability, which are taken from other systems. Going then kind of into the future maybe, portfolio level reuse optimization. You can, because everything is in this sort of embedding space, you can fly through this whole map of your entire parts portfolio and analyze a risk and replacement candidates there. And this is an example of such a risk assessment at the portfolio level. So we have a very simple query: which parts are near obsolescence risk this quarter? And it will go through the entire parts library, look at the shapes and functional information and supplier information, and actually make this a very valuable report, plus replacement options. So that's in a nutshell what we're doing with 3D CAD understanding by frontier models. Multimodal AI is here for engineering, and now it can also understand 3D. We are able to input from a variety of CAD systems and use them with modern agentic AI and RAG. And the special value is in connecting the dots between these 3D models and all of your other engineering documentation. So come see us at our booth, E67 Hall 11, or happy to answer a few questions now. Thank you.